Unit 8, what are we on? Unit 8 test review, page 2. Here we go. Um, Quadrilateral ABCD is a parallelogram. All right, so we know it's parallelogram. That means we get a ton of stuff for free, right? We know the opposite sides are congruent. The opposite sides are parallel. The diagonals bisect. The opposite angles are congruent. The consecutive angles are supplementary. Right? So we get all of that stuff for free. All we have to do is read the directions, which you guys are not very good at. So please read your directions, okay? It's parallelogram. What does that tell us? Well, we know angle 1 is 50, so I'm going to throw 50 right here. All right, we know angle 8 is 20. All right, so that entire corner is 70, right? Then angle ABC, ABC. All right, this entire angle they're asking for, angle ABC. What is that equal to? All right, well, wow, let me try that again. All right, so the opposite sides are parallel. So that means we have some same side interior angles. We know same side interior angles have to be supplementary. All right. So we have a 110-degree angle right there. All right. So angle 2 and 3 together are 110. I don't know if they are individually. I don't care what angle 2 is. I don't care what angle 3 is. I know that that entire top corner there, angle ABC, is 110 degrees. All right. Next one, if BD is 14, where is BD? So BD, that is a diagonal. So if BD is 14 and AC is 10, so let's see here, you got 14, you got 10, oh, the entire diagonal. All right, this is 14. This guy is a 10. What are they asking for? They want to know what EB is. All right. Well, again, diagonals bisect. Remember, they chop each other in half. So these two sections or those two segments are congruent. So if the whole thing's 14, then EB is just half of it. So that needs to be 7. All right. So this part right here, AC is 10. That's extra information, right? So we don't even need that, to answer this question. All right. Number 17 here. If AB, I'm just going to clear all this. AB is 2x minus 6, and BC is x plus 6. DC is x plus 8. All right. So I'm just going to write this in. We have 2x minus 6. Guys, I give you a picture. Okay, draw all over it. All right. BC is x plus 6. DC is x plus 8. All right. What do we do? Well, again, we know the opposite sides in a parallelogram are congruent. What does congruent mean? That means they're equal, right? That means they have the same length here. So I'm just going to say 2x minus 6 equals x plus 8. All right. Solve for x. Subtract the x over, add the 6 over. All right, we're going to have x equals 14. All right, x equals 14. All right, so again, this part right here, BC equals x plus 6. That's extra information. All right, that's in there to try to throw you off. All right, some people are probably going to set those two things equal to each other by mistake. All right, so we just have to be very careful. We have to remember the properties we are given here. All right, now if I had said this was a different shape, our setup might have looked a little bit different. All right, so just make sure you are using the correct properties here. All right, number 18. Do I have 18 over here? I do. All right, so number 18. If angle DAB, so let's find DAB here, is this entire corner. All right, angle DAB is 2x. All right, and ABC, so that entire top corner is 2x plus 20. They want to solve for x. So again, this is just like that very first one we did. Those two angles, all right, angle DAB and angle ABC are supplementary because those are same side interior angles. So let's just say, okay, 2x plus 2x plus 20, this equals 180 degrees. All right, so again, if you want to think about it, here's my two parallel lines. 2x, 2x plus 20. All right, ignore those diagonals in there, right? We can just think about the entire angles. Since they're parallel, same side interior angles, supplementary, and of course, supplementary means they equal 180 degrees, all right? So now just standard solving from here. Let's go over this direction. I got 4x. I'm going to go ahead and subtract the 20 over. I got 4x equals 100. And 60, divide the 4 on both sides, and we will have x equals 40 here, all right? The next one, AE and AC. Okay, so this one slightly different. We know, again, diagonals bisect, so those two things are equal. So I know AE is congruent to EC, right? But if we look at this problem, they don't give us EC. They give us AE and AC, all right? So another way that we could think about this is I can say, all right, if I take AE and I double it, all right, I multiply it by 2, that is going to be equal to the entire length of AC, all right? And that is the setup we have to use with this equation. All right, so sometimes we have to make new equations here to help us out. So I'm going to say 2, it's a different color, 2 times AE, 2x minus 7 is going to be equal to AC, which is x plus 13. All right, so really be careful. Watch those parentheses, all right? If you don't put those parentheses in there, you're gonna might get the wrong answer. You don't want to forget to distribute. So let's go ahead and do that. You get 4x minus 14 equals x plus 13. All right, I'm gonna subtract an x. I'm gonna add the 14 over, and we'll have 3x equals 27. Divide both sides by 3. You have x equals 9. All right, and then you move on to the next problem, and I take off a point because you didn't answer the full question. They want to know what is AC, right? Well, AC is 9 plus 13. So that's going to give us a 22. So again, make sure you're answering the question in its entirety, okay? So like if you look at number 18, they said solve for x. If you look at number 19, they said find AC, right? So not only do we have to solve for x, we have to plug it back in, right? So that's just something to really watch out for when we're doing these problems. You don't want to miss out on easy points. Solving for x is always the hard part, right? Plugging in is the easy part. Don't skip the easy parts. All right, last one. If BE is 2x minus y, ED is 18. All right, so they're giving us some diagonals. All right, AE is x plus y, and EC is 2y plus 6. All right, so we know in this picture, I got BE. Since, again, this is a parallelogram, BE is congruent to ED. All right, so let's use that idea. So I got 2x minus y equals 18. All right, now if you look at that, I got 2 letters. All right, so I can't solve an equation with 2 letters. All right, so what I need is a second equation. And that second equation comes from the following. Just look at the other diagonals. We know AE is congruent to EC. All right, so let's make an equation out of that. We have x plus y equals 2y plus 6. All right, so we're going to use these two equations. All right, we're going to have to make a system here. Now, if you kind of think about the systems, a lot of times when, in this class, we've been using elimination. So elimination, we have ax plus by equals c. All right, so that's kind of your standard form of an equation. If you notice how, just kind of look at it, x and y, they're in the same side of the equation. And then c is just some number without a letter. That's by itself. If you look at kind of this first equation here, x and y are on the same side, all right? So that one's ready to go. But if you look at the purple equation, I got y's on both sides, all right? So we sometimes need to manipulate these equations to get it into that standard form. So if we look at this purple one, I'm going to go ahead and subtract the 2y on both sides. And what we have is x minus y equals 6. All right? So now we can take both of these equations and we can stack them on top of each other. Okay, this is our system of equations here. So we have 2x minus y equals 18. And we have our x minus y, that equals 6. All right, now, a lot of times we add these together and we hope to eliminate a letter. All right, so sometimes it doesn't always work. If I just look at this problem, if I add these straight down, I have 3x plus 2y. How about minus 2y? 3x minus 2y, that equals 24. Okay, that doesn't help me any. All right, I still have x's and I still have y's. All right, the whole purpose for this is to eliminate a letter. All right, so what I'm going to do is I need to change one of these equations. So I'm going to take this bottom one and I'm going to multiply it by a -1. All right, so when I do that, I have negative x plus y equals -6. All right, the top one I didn't change at all, so I'm just going to drag it over. All right, 2x minus y equals 18. All right, so now if I add these straight down, now they'll cancel. Look at those y's. They're the same number, but they're just different signs. All right, one's a -1, one is a +1. That means they will eliminate. So 2x minus x is an x. I got x equals 12. All right, since x equals 12, let's just go ahead, plug it back in here. I got 12 minus y equals 6. Therefore, I get negative y equals -6. Subtract 12 on both sides. Divide both sides by a -1, and I got y equals 6. All right, and that one's done. Let's see here. I think that was the first part. I think this is just a... Okay, so I got 4 more. Now we're on to trapezoids. So again, this is a trapezoid. Trapezoid is it's not a parallelogram. All right, so this is kind of the only non-parallelogram we really talked about. We didn't talk about kites too much. So what do we know about a trapezoid? Trapezoids, the top and the bottom segments are parallel. All right, the left and the right are not parallel. Or I guess I should say exactly one pair of opposite sides are parallel. Now, if it's an isosceles trapezoid, then the two legs are going to be congruent. We don't know that second part. All we know is that the bases are parallel. All right. Now, there is this idea that we talked about with a with a trapezoid, a median. All right, so a median was when you had two midpoints. All right, I know G is a midpoint because we have those tick marks. This is GH is congruent to GF. All right, so G is a midpoint. Similarly, J is a midpoint. All right, so GJ is a median. So that means it's also parallel to the top and the bottom. And we also know that GJ is equal to HI plus FK divided by 2. All right, the top plus the bottom divided by 2 gives you that middle piece. All right, so that's something that you're going to have to remember. That's not a formula that well, do I give you that one? I don't think I give you that one. All right, maybe I do. I can't remember. Don't bank on it. All right, but let's just plug in what we know. All right, we know KF is 21. We know GJ is 18. All right, so I'm going to say 18 equals HI. I don't know HI, so we'll leave it as HI. Ooh, that looks sloppy, sorry. Plus FK, which is 21. We're going to divide that by 2. All right. Now, anytime you divide, I need to fix that. I'm sorry. That's a little bit better. All right. The whole right side is being divided by 2. All right, so I'm going to multiply the right side by 2. And the whole point of doing that is to cancel out those 2's. All right, do not distribute that 2 on the top there. So we have 36 equals HI plus 21. Don't you dare call that a 42. All right, and then subtract 21 over, you got HI equals What is that, 15 maybe? We'll say 15. Yeah. All right. So HI is 15. All right. And we could always check that. What is 15 plus the bottom piece was 21? Right. Divide that by 2. Let's see, that gives us 36. 36 over 2 gives us 18, which was what GJ was equal to. All right, so it worked out. All right, so that one is done. Remember, that had to do with the median. All right, if you don't remember what a median is, that's something that you're going to have to commit to memory. All right, so look that one up. Top plus bottom divided by 2. All right, now the next one, unfortunately, just a little bit more groundwork. So I'm going to use this equation again, right? It's going to hold true still. So KF, HI, and GJ. All right, so I know 18, I'm just plugging it all into the same spot. 18 equals HI, so that's x plus 4, plus KF. Remember, KF and FK are the same thing. It's 3x. Divide that by 2. All right, so I'm going to go ahead and condense this down a little bit, combine any like terms on the top. I got a 4x plus 4 divided by 2. Now both of those numbers are even, so I could divide it through, but I just want to be consistent with what I did on the previous problem. So I'm going to go ahead and multiply both sides by 2. All right. So what we have here is 36 equals 4x plus 4. All right, do not distribute that 2 in. The whole purpose is to cancel them out. All right, and now we solve. All right, subtract 4 over, you get 32 equals 4x. Divided both by 4, I think that's an 8. All right, so 8 equals x. Right? And again, they're only asking us to solve for x in this one, all right? So we don't need to plug it back into anything, right? So that problem is done. And I think this page is done. Oh, no, it's not. All right, 2 more. Let's see. We have this trapezoid here. If it's isosceles, all right, so HIKF is isosceles if angle F is 45 degrees. They want to know what angle I is. All right, so remember, in a trapezoid, the top and the bottom are parallel. All right, so we know that this is 45. Therefore, we can use that idea of same side interior to get 135 up here, right? These two angles need to add up to 180. Now, the second part of this is they're saying it's isosceles, right? So that tells us that these legs are congruent. Now, if you think about an isosceles triangle, 2 equal sides means 2 equal angles. The same is going to be true for an isosceles trapezoid. So this bottom piece down here is 45, and this top base up here, base angle, sorry, is 135. All right, so in an isosceles trapezoid, there are 2 pairs of congruent angles. All right, those base angles are going to be congruent. So F is congruent to K, and H is congruent to I. All right, so this problem, angle I is 135 degrees. All right, now on the last one, I see a squared in there, so we're probably going to have to factor. So HI is x squared minus 4x, FK, and GJ. All right, so the middle one, 15, is equal to the top plus the bottom divided by 2. All right, so same thing as before. I'm just to be consistent, multiply both sides by 2. I should have condensed that step down first, so I'm going to do 2 steps in one here. I'm going to say 30 equals x squared plus x squared is 2x squared minus 4x. All right, so that's what's going on there. I did 2 steps in one. All right, I see an x squared, I see an x, I see a number, so let's go ahead and factor. I got a 0. 0 equals 2x squared minus 4x minus 30. All right, now we could factor this as is. You got the 2x in there, which makes factoring just slightly more difficult. What I'm going to do is I'm going to make life a lot easier. I'm going to divide both sides by a 2, right? And I'm allowed to do that, right? Because all of these numbers are divisible by 2, right? They're all even numbers here. So I can get rid of that leading coefficient if I want to. All right, so I get an x squared minus 2x minus 15. All right, and that's going to be much more easy for me to factor here. 0 equals, what do we got? X times x for sure. And then I'm going to say probably a 3 and a 5. It's a -2 when I add them together, so that means the bigger of the two numbers needs to be the negative. So that's the factoring. Don't forget the easy part. Set each factor equal to 0. You got x minus 5 equals 0. Therefore, x equals -3. And x equals 5. Now, we're not done. Right? We could be done, but we're not. We got to figure out what x is. Plug it back in. Don't plug it into the equation. All right, plug it into the picture. So look, think about these side lengths. We can't have negative side lengths. So if I think of hi, I know hi is equal to x squared minus 4x. All right, so let's plug them in. All right, I got -3 squared minus 4 times -3. All right, so that gives me 9 plus 12. All right, negative times a negative is a positive. That -3 squared is a positive. So hi has a side length of, what does that give us, 21? All right, let's plug it into the other one, fk. fk equals x squared. All right, so if we plug in the -3 here, again, -3 squared equals positive 9. All right, so the -3 looks good. All right, so that one's fine. Let's plug in the other one. I'll go up above it. Let's say you got 5 squared minus 4 times 5. All right, it's 25 minus 20 gives you a 5. And then, of course, 5 squared again equals 25. All right, so that one looks good as well. So I'm happy with that. Both of those answers work. -3 works, 5 works. Do not get rid of that -3 just because it's a negative number. All right. You should still check them, but it does not necessarily mean it's wrong because it's negative, right? But there you go. That's the end of this. I think that was the last one. We got 2 pages down, 3 more to go. So see you in the next one.